So, I just, and English is good for you guys, right? Yeah, pretty, yeah. All right, just making sure. So I just wanted to do a quick intro to data cleaning and why it's important and why exactly we should be cleaning our data. So what is it exactly? Data cleaning is taking raw data. Data cleaning is taking raw data and turning it from something like messy, not representative of what exactly you want to model, and you convert it into something that can be used by a computer without any troubles. So what are some so why should we clean our data? So first you have to ask, what is the purpose of data science? And so there's like these 4 parts of data science. First, you collect data, you fit that data to a model, and then you use those models to make predictions about maybe you're predicting the price of a stock or something in the science domain. And then the final end goal is you make some money somehow, or you advance science in some way. But so the problem is, if your data is not clean, each step of this process is going to fail. If you have dirty data, your model will fit the wrong data, your predictions will be wrong, and everything after that will also be wrong. So how do we know when to clean our data? So the data can't be directly fed into a model. So maybe instead of numbers, you have words for the numbers, which doesn't actually feed directly into a model. The data might not represent reality, or it might be biased. And the data might be labeled or improperly, or have missing values, which is what we'll be studying mostly today. So this, for example, so imagine you have this data set, and for whatever reason, the person who was recording the data decided that they wanted to use words for numbers instead of actual numbers. Those words aren't going to go through a model very well. You can't multiply words, and you can't get the average of words, right? So we need to clean the data so that a computer can easily understand it, and you'll be able to put it into a model, and it'll be able to do whatever needs to be done. So here's an example of biased or unrepresentative data. I'm not sure if you guys know any machine learning, but a typical example, so this is a classic example. You want to build a model that takes a picture and tells you, is this a cat or is it a dog? Pretty simple, right? Typically, you would have maybe 10,000 pictures of cat and 10,000 pictures of a dog. You feed this into the model, it learns from your pictures, and then able to predict, given any picture, is this a cat or is it a dog? So it's pretty simple, right? But the problem is, if you have bad data, your models will never be accurate because you're not training on the right data. So suppose you've been trying to train this model for a long time. You can only get 50% accuracy, let's say. The first place you should look is your data. The model almost is never where the problem lies. It's in your data. So if we took a look into the data set, so here's just a funny example, I guess. So a common problem, if you're scraping the web for your pictures or something like that, and you just scrape for dog pictures and scrape for cat pictures, you're going to get a lot of stuff that is not representative of what you're trying to model. So you might have duplicate data here. You might have the wrong thing in your data set. You might have blurry pictures, and a lot of the times you're going to have a lot of ads in and weird data, or it just won't be something that you're trying to model at all. So what you really want to do is make sure your data is accurate, and this will give you good models. So if you have just plain bad data, your results are going to be all over the place. If your data is let's say a little dirty, you might have a couple of dog pictures where there should be cat pictures, something like that. You might get a little bit accurate, but not very precise. Let's say you gave it 1,000,000 pictures of dogs, but only one picture of a cat, or 100 pictures. Your model is going to be biased towards picking one thing instead of actually picking the right thing. Just because statistically, if you were to give it 1,000,000 pictures of a dog instead of having a balanced data set, on average, when it picks a dog, it's right most of the time because there's just so many more dog pictures. So you want your data set to be representative of what you're trying to model, and then that's the only way you'll have accurate and precise data. So your data set is probably the most important part of data science, of course. And it'll define how well your models work. So missing data is what we'll mostly be going over today, I think. So some examples of how you can have missing data is maybe you had some sort of scientific instrument that was measuring temperature data over time or something, and it failed. And now you have like a block of time where there's no data. And so that might skew your data a bit. But you have to be really careful about how you fill in missing data, like null and NA fields, because that can also change how your model behaves in the end. So let's get on to the actual material.
Yeah.
Hello? Can you hear me now? Okay.
Yeah.
Hello, Dahua. Okay. Yeah. So this one changes what kind of bracket your bins has. So as you can see, this used to be a closed bracket on the right side, but now it's an open bracket. So it'll be everything. I guess it really just changes how it's printed out though, since these are the same thing. Everything up to but not including 26, but this is everything up to and not including 26, but it's just everything including 25. So it's essentially the same thing. So if you want to actually put labels on those bins that you made, then you can pass it this array, and same, you have to make sure it has the same size or the same length as the count of your bins. And then you can throw it in that cut function with your labels, and you'll actually get bins, and it will label your data as well. So you'll get bins that are more self-descriptive instead of 18 to 26, etc. Actually, I'm gonna check what happens if it's, yeah, so you'll get an error. You'll actually get an error if the number of labels doesn't match. So that's always, you always got to make sure of that kind of stuff, or you'll break your whole program. So let's see. Right, I think, yeah, this is just making bins from, it's cutting all your data into 4, I think. What is our data here? Oh, right, it's right here. So let's actually see what our data looks like. Yeah, so it's the same thing, except the range is now 0 to 100. I think it's just because it's dividing it by 4. So if we have 5, it'll do the same thing, but it'll split it into 5 bins, and you can make 100 bins if you want, and it'll get really messy. But yeah, this is if you want like a precise number of bins, and if you want it to be within that range. I think actually, okay, it takes the lowest number, I think. Possibly. And then the highest number, possibly. And then splits it in 4. So I wonder, yeah, so you can see the range will change since it's random. Those bins are changing because the numbers in our set are random here. So I actually changed this one because I thought it's easier to like visualize quartiles if it's 0 to 1,000. So this one is splitting it into quartiles, which is like quarters, and you can see the bins have exactly the same amount because we're going from 0 to 1,000, which is pretty simple there. And this one, it's also going, it's the same thing, but actually, not sure here. I think this is setting what your bins are. But what is this array here? I can't remember. Oh, okay, okay. So this is defining the quartiles? Yeah, okay. Yeah, so this goes to 100. This goes to 500, which is 50%. This one goes to 90%, 899, etc. Pretty simple. Okay, so filtering outliers is pretty useful because if you have a bunch of outliers in your data, it's just going to skew it all over the place. So you can get a bunch of useful information if you use this describe function. And like the mean, standard deviations, which should be around 1 since we use this random normal function, standard random normal, I think, in the shape of 1004. Can actually print it out. Well, no, that's going to look all messy. But yeah, 1,000 objects or numbers. The mean should be 0 because when you use this rand n function, it's a standard distribution with a standard deviation of 1 and mean of 0 should be. So actually we can change the mean, I think, if we add 1 there. So you can actually move around that random normal distribution by adding a number to it. And that'll change the mean. And I think if you divide, you can change the standard deviation. So yeah, if you divide by 2, you'll squish the standard deviation. Yeah, they're sampled from the standard normal curve. Yeah. So if you want to column, I'm not sure exactly what this is doing. Yeah, okay. So you're getting this column, which is data at 2. So I like to visualize everything, so I'm just going to print out what the column is. So it's this big set of numbers. Oh yeah, so this is creating, yeah, 1,000, 4 columns of 1,000 random numbers, I think. So this is getting the second column, and it's returning everything. This right here will return everything that is greater than 3, which should be nothing, right? Yeah, there shouldn't be any values greater than 3. So maybe 0.2. There you go. All of these. So it's similar to what we did earlier, where you can actually get this new array of, and just put this kind of Boolean value in here, and you'll actually get a new array out of that. So this one only had 312 elements in it. This one will get any. Okay, I'm going to change the data so that it is actually proper again. So this will get any row with where the data is greater than 3. Okay, so if any one of these rows has a value that's greater than 3, the absolute value, it'll take the whole row. So if it has any one value in there that's greater than 3, then it'll take the whole row. So there's 3 there, there's 3 there, 3 there. If we wanted 2, okay, there's no value. Oh, so that's the axis. Let's see. Interesting. I could have swore you can put 2 and 3 in there. Maybe my MP knowledge is a little rusty there, but this is taking any row with a 3 in it. Any one row with that absolute value there. Let's see. So this is assigning anywhere in the data where the data value is greater than 3, then it is using a sign function on the data. What exactly is sign now? Does anyone know that one? Oh, just return the sign? No, I'm not sure. Let's see. Can you say that again?
We have the sign equal negative, so return -1, if it is positive or negative, +1, and times 3, so you have either +3 or negative.
Oh, okay, gotcha. So let's see. So if it's greater than 3, oh, okay, yeah. So this is how you make a max value, right? So if it's, oh, okay. So take the sign and multiply by 3. So there shouldn't be any values here greater than 3 then, right? Well, see, it assigned it to exactly 3. So essentially what this is doing here is it's saying if anything's greater than 3, then just make it 3. Yeah. But keep the sign. Yeah. No, it keeps the sign. So this, yeah, it'll keep the sign, but it'll be capped as 3. So there'll probably be a lot more 2s. So there's a 2. I don't see any positive 2s though. But yeah, that's what it's saying. There you go. So yeah, it's setting the maximum value. So it's kind of like squeezing your data into like a smaller frame so that any outliers will just be capped at that value. And this will just give you the sign of, I'm not sure. Oh no, this is the first 5 elements. It gives you the sign. So that's positive, negative. Yeah. So if you just want the sign of your data, then that's how you do it. Use this sign of your data. And then this is just the first 5 as learned before. Okay, so permutation and random sampling. So sure many of you know what permutations are. So, oh no? Okay, that's all right. So it essentially takes these numbers in this column and it just puts them in a random order. So like a permutation is like one way of arranging a set of numbers. So one permutation might be this 4 is here and the 0 is here instead. That's one way of arranging numbers. So this one is actually, so right here you can see this sampler. So sampler, you'll see what that does in a second. It essentially returns an array of where the index, so this right here number is going to be replaced with whatever's in the second index. So, sorry, this number here will be replaced with whatever in the second index. So it's going to be replaced with 8. Okay. This 4 is 16. It's going to go in place of the second number. And 1 will go in place. So we'll just show you what the actual, so there you go. We have 8 Why is it 8? Because 2 is this first element in this array, and 2 indexes to this 8. So it's saying replace this number with whatever was in the second index of the column. Does that make sense? Not clear? Or clear as mud? Okay. And it's pretty much just doing that for every row. It's using the same array for each row though. I mean column, sorry. So the second number 2 should be this guy, 9. 9 should be first. There it is, 9. So it's just a way to kind of like randomize your data a bit and like shuffle it up. Just the columns. So it makes a permutation, they call it. So it. Well, it's the rows and columns. It's only the rows because the columns are getting permutated. So since these are getting randomized, it's also the rows getting randomized. But these values 1, 2, 3 aren't here, right? If it was the rows, then this would be some combination of 1, 2, and 3, or 0, 1, 2, 3. So as you can see, the first row is 0, 1, 2, 3, right? But now the first row is 8, 9, 10, 11. Oh, okay, yeah, it is kind of like that, I guess. Well, yeah, it's because each column. Okay, yeah, maybe that's just a fun. I think we both know what it's doing, but like, yeah, it takes. Yeah, like these remain the same, right? But it's just moved to here because that's the number in this array. But actually what's really happening is it's mixing up on this axis. So like that, and then sampler. Yeah, it's the same. It looks the same. So they should be the same. And they are exactly the same. No, so none of these change the original data. So the fact that I can print that means it's something is being passed into this print function and it's being printed. So this, if you know what I mean, right? Yeah, so this one just selects this random subset. Yeah, so it'll take a random subset of your rows and just give you n equals whatever you put in here. So like n equals 4. It's essentially the same. I think it skips the sampler step though here. Okay, so if you use replace, then it actually allows you to choose the same value more than once. So so this is picking randomly from here, and it'll the value can be as you can see here, it can be the same value more than once. So it'll just pick a random permutation. You could also see that with this guy as well, probably. If we did that and made that 10, it would just randomly pick rows and then put them in a random order. Just a way to get more random data, I suppose. Okay. So indicator / dummy variables. So do this. This one kind of makes categories in a way. So if it's B, there will be a 1 in this column, or sorry, in this. In the column. So essentially, it takes if the value is present, then there will be a 1 in this part, in this column. That's the best way I can describe it. Is that clear enough? No? I can elaborate more, I think. But has anyone done any machine learning stuff before? Labels? Yeah, so this actually makes kind of like a label vector. So exactly, so this isn't exactly one hot because there can be more than one value in this vector here, but this is close to one hot encoding. So what is you're probably asking, what does he mean by one hot? Pretty much when you have a label, you can, let's say, going back to that example of cat or dog, you usually, you have to give it a label so that it knows if it's correct or not. And the way we do that is with vectors called one-hot vectors. So essentially how it works is if this value is 1 and this is 0, then that's a cat. If this value is 0 and this is 1, then it's a dog. Pretty simple, right? So those are called one-hot vectors. I think this way is a way of getting similar vectors like that. Yeah, so in this row, so the first value of this array can be encoded as a vector of 1, 0, 1. So that means that this label is 1. Yeah, you could throw this in. Exactly. Exactly. It's kind of like f. If you had some function, f at like whatever your image is that you're labeling or you're predicting equals some vector y, and y would just, this is kind of getting too complicated, I think, but y would be this vector here. So when you would predict, given an image, what is the label? What is the vector? And then usually your algorithm or whatever you use will try and predict a vector like this, but it might be more like 0.94 and 0.06 or whatever. That's called a one-hot encoding because you're encoding this row. If it's a B, then it's 0, 1, 0. If it's a C, then it's 0, 0, 1. So that could be the difference of like, this is a dog, this is a cat, and this is neither, that kind of thing. You're encoding it like that. It's easier to once you actually do some model training and stuff, it's like pretty straightforward. But in this case, it's kind of abstract. Yeah. So yeah, this would be you'd if you were doing some prediction algorithm, maybe like classification. And it also depends though. You can define it like only give me one or give me the probability that it's one. So most algorithms will use top 5 probability kind of thing. So like the top 5 percentages will only be considered. And yeah, so they will give you this pretty much. You'll give it an image and it'll give you a vector, and you can determine what the thing is. That's like the end goal of most models that are at least classification models. Yeah. But you would pass this whole array into your like fit function but that's a whole nother thing. So I don't think we'll go too far into that. Okay, so I think this is just labeling the axis, or I think this is just giving names to these labels here. So here's your old data. I think. And it's joining it with your dummy variables here. Not exactly sure what it's doing. Anyone have any insights here?
I think it's almost like because you have three columns. Each column represents the key A represents the column or the category A. For example, your original data, the row 1, there's no A, so it's 0. But row number 2, in the original data there's A, so it gives value 1, similar to the EB and PC. If you print out the original data set like DS.
So you mean this? Print out these dummies?
Not just the original data. Yeah.
Oh, this guy.
Yeah.
Oh, yeah. Okay.
Sounds like transform column. Only you have transform that.
Oh, yeah.
It's like
yeah. Okay. Yeah, I see. So this is the. If this is 1, it's A. If this one is B, etc. Kind of like that. Okay. Right. So this is that example of using an entire data set, and where one-hot encoding gets kind of messy because there are some classification problems where you actually have more than one label. So like instead of asking it, is there a cat or a dog, you ask, is there a cat and is there a dog and is there, like, you can give it as many vectors as you want. So where this is kind of reflected is a movie can have multiple genres. So you'll have to encode that in such a way that it will have the data for each genre as a 1 in that vector. So here we're going to get all the genres. Just going to print it here. So we have a nice map of or just an array of all our genres. And we want to make a matrix of size, length, movies, multiplied by length of your genres. So for every movie, we have we have a row for every, for every movie you'll have an encoding with a 0 or a 1 for which genre. So actually it's better if you just see it. So this one is just splitting. Let me use columns, get indexer. Okay, it's better to see the final result. So it's killing my computer doing this. So I think this is one row. So this is the one hot encoding. So this one actually is a one hot. So for every movie you have, you're gonna have this super long vector of encodings. So if there's a 1 there, that means it belongs to that category. So as you can see from before, so Toy Story was animation, children, and comedy. So here we have animation, children, and comedy. So it looks like it just kind of appended on genre underscore animation somewhere over here, right here. So it's joining the name of the movie, or sorry, the movie data set, and adding genre to each of these. Yeah, and I think this is just cutting them into bins. So for each genre, actually, I'm not sure. This part was a little weird for me. I think this is an unrelated example here. But it's splitting it into bins, so it's cutting the values here. What is values? How is this related? Is it related at all to the old one? Oh, okay. Oh, it's like the one hot encoding, but for bins, right? Okay. Oh, right. So the first one has, okay, yeah. So this is making the same thing, one hot encodings, but we're using that thing we learned previously, this cut. We're splitting it into bins. And then if 2 is in that bin, we have, or if it's in that bin, we'll have 1 in that place there in that table. So yeah, these are also one hot type encodings as well. Okay. And then, okay, so, right, this was like a little example I did. So here we have string object methods. So you can split a string by giving it this, it's called a delimiter. And so you give it, let's say, this right here, it'll split your string at any point where it has that. So, and it'll return an array. So Also know that it doesn't actually keep the splitter, like the delimiter. It'll just cut it up and give you any words before or after. So a good example of how I usually use this is if you want to get, like, let's say the file extension of a file. So do you guys know what -1 of an index is? Yeah. So you'll get the last element of a list at the -1 index. So this example, so in our examples folder, you can actually, let's say for every file, and this actually gives you every file in a directory. So you can take every file and you can get its extension, and then you can kind of map each file to its extension type. So this will give you like a tag for every text file. It'll give you this array of texts or something like that. It works really good if let's say you have thousands of images or something, and you want to get like a map of all your images, or you have a bunch of CSV files, and you can use this to kind of organize stuff just by scripting. So x.strip will strip any white space. So right here is our white space. It'll actually remove that, and here is making an array. So for every element x, strip it in this, which is actually this right here. So now you'll have no white space. So here's our new string here. So you can actually, oops, sorry. This will actually join an array on using this. So this is pretty useful for, like, let's say you had an array, like, this is supposed to be, pieces is supposed to be an array. Oh yeah, it is. So what it does is it takes every element in this array and it'll combine them together with whatever this value is. So as you can see, there goes A, and then adds this character, and then B, and then adds this character, and they'll do it for a whole list. A way I usually use this is if you want to make your own CSV file, then you can split all your values with a comma, and then just print it to a file, and you can use that if you want to make your own type of CSV file. Okay, so this will print the index, the first index, I believe, of this delimiter in a string. So going back to our value, our array here, it's right here. So you can see this would be the 0 index, that would be the first index. It got the first one. But if you use find, it'll return that the first index as well. So if we did that, but if it is not in the string, then you'll get a -1 if you use find. But if you use index, it'll actually throw an error if you. So right here, if you tried to find this in that value, you get a value error because it doesn't exist. But if you're smart, you'll put it in a try catch block like this, and you'll catch your exception and return something else. So this is just something I wrote. It's pretty simple. I'm not sure. Have you guys done exceptions before? Worked with exceptions? Okay, good. This will just count how many commas are in there. 2, which makes sense. And using replace, you can replace any value with whatever you want. So it'll replace, sorry, that's the second one. This will replace any comma with that character. Okay, not too much more. Okay, so regular expressions. Anyone dealt with these before? Just wondering. Okay. These can be kind of complicated, but essentially you give it a pattern and it'll find that pattern, and then you can either replace it or you can extract info from it. So this S right here is the character for a space, and the plus means find the space and then keep removing spaces until yeah, so remove all spaces until you hit like another character or something like that. So that's why when we split it there, it didn't include all these spaces here. So, and that /t is a tab character, which is space, I think, like 4 spaces. With the new line?
Yeah.
So you mean like this?
No, if you do the text,
if you had a /n here? It'll keep everything after that new line. Yeah, so if you don't know, a /t means a tab, like a tab character. So one way that I've used this before is when you're parsing XML. So sometimes you'll have like these data structures in XML. So this is actually a transaction, or like it's customer info. So you'll have maybe their card number, their expiry date, their security code, and that kind of stuff. So you can extract that from the text using a pattern. So this is pretty much saying find anything with an open bracket or a tag, this tag right here, like this. Take the word inside of it. So using this expression. So does this make sense to you? This, what's inside here? Yeah, so it's essentially saying like, okay, these are the allowed characters of your regular expression. So your pattern. So look for anything in the range A to Z. So A all the way up to Z. Look for anything in the range 0 to 9. And these characters are also allowed. So a period, underscore, %, plus, minus. And then you put this in a bracket, and this plus sign means keep going until you find the next part of your expression. So it's kind of like the plus up here. Keep going until there's no more spaces, and then just take that word. So, and also these, if you want to extract the actual word, then you would use these brackets here, these circular brackets. So I'll run that. This is the XML. So this actually got me each type in these tags. So like this, for example, right here. Or well, yeah, but you can see you can extract the info from these tags using regular expressions, which is really useful, especially if you're data mining or something like that. Oh yeah, that this is like the standard regular expression thing here. I'm actually going to go down and go to the simpler example though. This is I just wanted to show like what people use it for, because another thing you can use it for is like if you're going to send this data over the internet, you might want to encode this data in a way that can't be stolen. Like if someone can take packets over the internet, you want to have like encrypt this may be hidden or something like that, so no one can just look at it and steal it. So making a regex, you actually use this compile method to make a regex, and then this is just that same example up here, I think. So compilation just kind of you can set certain rules. So like down here, you can set a flag like ignore case. So lowercase, uppercase doesn't matter. And that's why in here there's no like lowercase a to z, it's just all a to z, because it doesn't matter. And you can, so using find all, you find every occurrence of the thing you're looking for. I think I kind of broke it though when I changed it here though. So let me just run that again. Okay, yeah, so what this is saying, so it's finding everything based on what you compiled the pattern to be. So our pattern was S+, which was the spaces. So it's just finding anywhere where there were spaces, and it's making an array. So these are all the places where it followed that pattern of having spaces. So that's, I don't think that's a very good example. I think this one's a much better example. So here we have like a set of emails and names. So yeah, this, oh, and also remember you have to put this R here to denote that it's a regular expression. So having this R kind of tag beside your string will let the regex compiler know that it's a pattern that you're handing in. And oh yeah. Yeah, you can also do that using the triple quotes. So if you use these triple quotes, you can have quotes inside of your strings without it exploding, as we call it. So this pattern is the same pattern that we just looked at, kind of. So it says find anything with letters or numbers or symbols, plus an @ sign for emails, then another word. So right, like find Ryan at, and then another word, Yahoo, and then here's a dot character or a period, so dot, and then .com should only have letters. Well, let's see. I think it's
if you use a backslash, it's just escape dash, so it means just
right. It would be like this. If we wanted to find a plus sign, we'd probably have to put that there. Oh, sorry, I have insert on. So it's telling it like we actually want the plus. We don't want to find a string and keep going until the end of the word. So I mean, that would probably break everything if I do that. Yeah, so this is just finding any email. So this should return just the emails. So when you have to compile it first with your pattern, and if you want to ignore case, that's what you do. And then when you run find all, it'll give you all the emails. So pretty simple. And so this will search, where's our text? Right, text. So this finds, this is searching the text. What is M again? So I'm pretty sure this is finding the first, it searches for the first occurrence. And then the start is the index in the text where it starts. And then the end is the final index of that word in the text. So I think 5 here is where Dave, the email starts. So this is the 5th index. And then here you can see 20. So this is the 20th. And so it's saying, out of that text, give me the word from in that index range. Did I remove something there? Yeah, so this, was there something there? So anyways, if you want to replace certain things in your text, anywhere where you find a match to your pattern, you use this sub method. So this will actually put this redacted on any email. Oops. So any match of your pattern will be replaced with what you're subbing with. And this is kind of similar to what I showed you above here, where you're getting these brackets. If you put these brackets in these round brackets in your regular expression, you're going to get an array of each of those elements in that bracket. So what I mean should be find all. So everything in these round brackets here will be part of a list or a tuple, sorry. So you'll get a 3 tuple here. So these will be an element, each of these will be an element in that tuple. So that's pretty useful. And this is just doing the same thing with this string by using the match. Except it's showing the groups. I think it's essentially the same thing. And this one is so these slash characters will just replace sorry. These are kind of like parameters in your string. And the first parameter corresponds to the first in the tuple of the thing you found. So in the second one will be this, and there will be that. And this is just a way that so you can change that entire string. So this is the location of that username, and this is the location here, and so on. That's pretty clear, right? I think. Okay. All right, almost done, guys. I'm losing energy here. Okay. Vectorized strings. Oh, okay. Same thing. This is creating this data frame from this map here. We've already seen this earlier today. If it's null, it'll return true. This is another way of just checking if anywhere in that data frame you have contains the word Gmail or whatever you want. So you can see these guys have Gmail. So it'll return a series here where true is wherever there's a Gmail. And apparently not a number if it's not even anything. Supposedly because you can't really check if a string contains something if it doesn't exist. So you can actually use those patterns that we were just using earlier inside of a data frame as well, using the string attribute here and using find all exactly in the same way that we used it with the regex, except this is where you would have compiled it, but instead we're just passing the pattern and it probably compiles it itself inside of the object itself. This one will return true if any of these match the pattern that you gave it. I'm not sure about this one. So matches. I'm actually not too sure what this is doing, to be honest. This is the matches. Yeah, okay. Like the second here. Oh, okay. These are just getters and all right. And this one? I'm not too sure. Oh, yeah, this is just ways you can retrieve stuff. Okay. Yeah. So any string in there, just give me the first 5 letters. And this just changes how many rows you show when you print stuff. I don't know why it's at the end. Oh, okay. Descriptive enough. Tell me how.